In this lab, you will implement various classifiers such as SVM and apply these classifiers to malware data. In order to accomplish this lab exercise, you need access to a computer with Python version 2.7 or later, as well as a Python IDE installed. You need the sample malware data from Kaggle to accomplish this exercise. The link to the data is provided in the exercise. In this task, you should create classifiers such as decision tree, SVM, and naive Bayes. You will learn the concept of k-fold cross-validation to compute the classifier accuracy or prediction performance. You can use software packages such as the scikit-learn package to accomplish this task. So now let's look at the solution. The solution takes a long time to run, so I ran it ahead of time to get the results. For this project, we will use the sample malware data from Kaggle. For this exercise, we are using the bytes files. Here's an example of a bytes file. This is the data. This part here is the data, and then this is the offset. We are using the data to compute the accuracy. We have this bags of words classifiers.py file. This contains all of the classification algorithms. But if you prefer, you can run each algorithm separately using these files here. For example, bag of words decision tree would just run the decision tree algorithm. In the main of this file, we notice that we are printing out the accuracy scores for decision tree, naive Bayes, and SVM. Here's the decision tree function. We notice that for the decision tree, we are training the decision tree classifier, and then we are using cross-validation score to compute the accuracy. In this, you can see that we are using 5 different cross-validation scores in order to compute the accuracy. Then we print out the decision tree accuracy. We do a similar thing for naive Bayes. Naive Bayes also uses 5 different cross-validation scores to compute the accuracy, and then we print out the accuracy for naive Bayes. SVM also uses 5 cross-validation scores to compute the accuracy. So now that we ran the program, we can see the result. So if we go here, we can see that the decision tree has a 85% accuracy, plus or minus 11%, which is the margin of error. We could also see that the naive Bayes classifier has 72% accuracy, which is less than the decision tree accuracy. And then we see that the SVM classifier has 71% accuracy. So for this exercise, we would prefer using decision trees to classify the malware because it has the highest accuracy of 85%. This concludes Lab 2 of Module 2.